Hello guys, and welcome to the part 3 of Ethernaut challenge. So this is a coin flipping game where you need to build up your winning streak by guessing the outcome of a coin. So if you can guess the correct outcome 10 times in a row, we can win the game. So as usual, we create a new instance. Okay, transaction has been mined. So this contract may look like a random number that is guessing a random number based on this, and since for every transaction the block hash changes and the block number also changes, we need to hack into this contract, and the way to do that is using another contract. So I'll power up my red mix here. I'll create CoinFlip, and so this is CoinFlip. So this contract will be our contract here, which is this contract, because we need the structure of this contract. But I would not like to copy this whole contract, because then I will have to use this import here, which means I'll have to download safe math. But I will not want to do that, so I'll create an interface. I'll create an interface instead, and this interface will be this. So we just need the flip function, which is this here. Okay. And since it's an interface, this will be external. We'll create a contract that will hack this coin flip. So we'll create a contract right here. Let's call this hack. Oh, let's call this hack. Let's do it this way. And we'll have this. And we'll have a boolean, which will be public. This will be side. And we need to get this contract by address. So we need this also. And this will be coin flip. Okay, let's call this CoinFlip. Let's just call this CoinFlip. So this is an address, and we have a constructor that will initialize this our conflict contract for us. So a constructor, and in this constructor we need to initialize this variable. So we'll do this. It should equal CoinFlip address. No, not this CoinFlip. It should equal CoinFlip address. And address, let's just pass it here. Let's pass the address here. And so we should call this address. We need to create a function that will call this flip method and predict the results for 10 times. All we have to do is look at the coin flip algorithm to see how they generate their numbers. So here they get the block hash of every transaction. So once a user causes flip is a new transaction, they get the block number of the previous transaction and convert it to a block hash and convert it to an int. And then just to be sure that the user is not trying to hack by using the same block hash, they use this to reverse it, and they divide the block hash by the factor, which is this, which it doesn't change. The way to go about this is to send 10 transactions at the same time. For a single transaction we are calling this flip function 10 times. We'll go back to our smart contracts. So here we need to create a function. We'll call this hack. Let's call this hack. So this function is public, but we need to use the same algorithm as them. So their block value is this. Let's do this. Their conflip is this. Let's also use this too. Since we don't have the safe math here, we can't use this div, so we just do this like this. Can't use sub, so we'll use -1. These are the safe math library functions, so we can't use it because we don't have it. So we'll do this. I use block hash directly, and we get the block number. We convert it to a hash, and all we have to do here is convert this to uint. Convert this to uint. I think we need to convert this also to uint. The trick here is that we're using the same block number right here. We're using the same previous block number. Since we've declared the side up here, we don't need to declare this again. What we have to do now is to call the flip function right here. So to call the flip function right there, we'll just do CoinFlip. What is CoinFlip? CoinFlip flip. We need to set the guess. The guess should be side. So right now we are doing the same calculation as the smart contracts which we are trying to hack. So for that reason, the smart contract will deliver the same results. Let's deploy this. Remember, we are on the testnet, so we need to switch to the testnet. Okay, and and let's deploy. Since this is an interface, let's deploy the hack function. This takes an address, so we need the address of this function, so we can do this. So this is the address, and we can pass it here. Deploy this. It has been confirmed. If we should hack, this should trigger the Ethernaut that is doing exactly the same calculation as ours. So meaning we are getting the same results. I'm trying to flip it based on the results we get. So we can confirm this. Oh, we got an error. Okay, let's see. Let's see the error. Let's see the error we got. We ran out of gas. Let's try giving it a higher gas. I just increased the gas limit. Let's see. Okay, transaction was successful. So let's see if we got it. Let's see our consecutive wins and contract consecutive wins. I just need to convert this to number. So you can see we've won once, and if you try hacking again, you just go 10, 100, 1, 2, 3. Let's just copy this. We'll confirm again. Transaction has been mined 2. Okay, it's confirmed right now. And once we check, we can see it's 2. You just have to spam the hack function 10 times. So we just have to spam it. Alright, so we've done it 9 times, and this is the last one. Let's just wait for the transaction to be completed. Okay, it's completed, and if you see we have 10 consecutive wins. We need to submit this instance just before we go, and click submit, and we submit this. Yes, we've completed this level 2. These are the options that you can use to generate a random number. Not generate a number with public variables. So that's all for this video. In the next video, we'll talk about telephone, and I'll see you in the next video.